Limits and Derivatives, Class 11, 13th chapter. In this chapter, we have completed exercise 13.2. Now we will solve a miscellaneous exercise. So there are 34 problems in the miscellaneous exercise. In the first heading, find the derivative using first principle. There are 4 sub-questions. So we have to find the derivative using first principle. Let us solve the first sub-question. So they have given a function f of x that is minus x. So this is the function they have given to us. So we have to find the derivative of the function, that is d by dx of this function, which is also denoted as f dash of x. So d by dx, f dash of x are both derivatives of the function f of x, and the function given to us is minus x. So let us find the derivative, that is, let us find f dash of x and d by dx of f of x. But they have specifically mentioned that we have to use first principle. So this is the first principle. This is what we want, right? Using first principle, this first principle, we will find the derivative of this function. The first sub-question, minus x. So we know that f dash of x, which is derivative, is equal to limit h tends to 0 f of x plus h minus f of x divided by h. So this is the first principle, right? Now using this, let us find f dash of x. So here we have to know what is f of x and f of x plus h. F of x is the given function. So f of x is equal to minus x. From this, f of x plus h, we'll just write here, let f of x plus h will be, in the place of x we have to write x plus h, but we have to put the bracket and we have to write the minus sign. If you don't put the bracket, then this will be wrong. Okay, so if you have x, you have written minus x. If you have x plus h, you will write minus of x plus h. Now let us substitute both in the f dash of x. So this implies f dash of x is equal to limit h tends to 0 minus x plus h minus, here you have to be very careful, you should not forget there is minus sign here and there is minus sign for f of x as well, okay, divided by h. Now this implies f dash of x is equal to limit h tends to 0, let us simplify this, minus x minus times plus minus h minus times minus plus x divided by h. Now this implies f dash of x is equal to limit h tends to 0, minus x plus x is 0, so we will get minus h by h. We cannot give h 0. If you give h 0, you will get 0 by 0 form, right? Our main intention is to avoid 0 in the denominator. That means we have to eliminate h from the denominator. Now f dash of x is equal to limit h tends to 0, h by h is 1 and we have minus sign here, right? Now this implies f dash of x is equal to constant, limit of the constant is minus 1. So this is the derivative of this function. So this is the function and this is the derivative. We can also write in this form, or d by dx of, see this form, d by dx of, what is the function we have defined? Minus x. D by dx of minus x is minus 1. Okay, just you can remember this once. D by dx of x is 1. D by dx of minus x is minus 1. So remember this piece of information. So we completed the first sub question. Now let us solve the second sub question using first principle. So the question is minus x to the power minus 1. What is this exactly? This is a function f of x. Now what we have to find? We have to find derivative of this, that is f dash of this, which is also denoted as d by dx of f of x, that is d by dx of this. Okay, but using what? Using first principle. This is what we want, but using first principle. Okay, so I've written the same first principle here. Now in order to simplify, we should know what is f of x and f of x plus h. F of x is the given function. So we will write let f of x is equal to minus x to the power minus 1. Here you have to be very careful. F of x plus h will be, so we'll put the bracket, we'll write the minus sign, but in the place of x we will write x plus h with the bracket. If you don't write the bracket, this will be wrong. So you have to write the brackets, then this minus sign. Okay, now we can also simplify this in this way. F of x is equal to, so when we have minus 1, we can write this as 1 by x and this minus sign, and this we can write as f of x plus h is equal to, we have minus 1, right? So we will write 1 divided by x plus h, but we have minus sign. Now let us substitute both in this equation. So this implies f dash of x is equal to limit h tends to 0 minus 1 divided by x plus h, minus is there, we are writing minus 1 by x, but don't forget to write this minus sign, divided by h. Now this implies f dash of x is equal to limit h tends to 0 minus 1 by x plus h, minus times minus is plus, 1 by x divided by h. Now this implies f dash of x is equal to limit h tends to 0, here we can take LCM. So what is the LCM here? Since there are two different things, we will write two different things, x, and here you will get minus x, and here you will get x plus h divided by h. Now this implies f dash of x is equal to limit h tends to 0 minus x plus h divided by x plus h into x, and we can bring this h here, 1 by h. How do we got 1 by h here? That you studied in the complex fraction, when you have a by b by c by d. When you have fraction by fraction, you will write a into, this bottom will come here, a into d, b into c. Okay, so a by b divided by c by d. If nothing is there means there is 1 here. Okay, now this will be a into d, a into d, b into c, b into c. Clear? This is from the complex fraction. Now this implies f dash of x is equal to limit h tends to 0 minus x plus x will neutralize. You will get h, x plus h into x divided by 1 by h. Now we know that if you have same term in the numerator and denominator, it will be 1, right? So if you have a by a, it is 1, correct? So now this implies f dash of x is equal to limit h tends to 0. In the numerator it is 1, in the denominator it is x plus h into x. Now can we give h equal to 0? Even if we give, we can avoid denominator 0, right? We can avoid denominator 0, right? So this implies f dash of x is equal to, so when you are substituting 0, you should not write limits. So you'll get 1 divided by x plus 0 into x. So this implies f dash of x is equal to 1 divided by x plus 0 is x into x is x square, right? So this is the derivative of this given function. So we can also write like this, d by dx of, what is the function here? Minus x to the power minus 1 is equal to 1 by x square. Right? Both are same. So this and this, so they are same. Just we denote in a different way. So we completed the second sub question.